Average rate of change? Well, rate of change is slope. Are we okay with that? Average rate of change is slope over an interval. So let's write that. Average rate of change would be slope on an interval. And an interval is these things with numbers in it. Are you okay with that? That's an interval. So it's slope on an interval. What I mean by that is, on a line, isn't the slope always the same? The rate of change. But on a parabola, do you see how my rate of change is constantly changing? Do you see if I find the slope between points on a parabola, it's constantly changing. And we're going to talk about that. It'll make more sense once I show you an example. So here's what I mean by that. Right here, I want to find the average rate of change from 0 to 1. So what that means is I'm going to plug in find the point at 0. See at 0, that's my height. And the value at 1. Can I put a dot right there? So go ahead and do that yourself. So I want these from 0 to 1. I'm going from the interval 0 to 1, and I found my 2 dots at 0 and at 1. Can you now find the slope of that line?
What does that word say?
Slope on an interval. So right here, here's my interval, 0 to 1. And what I'm going to do here is find the slope of that line. Now, is that slope line almost accurate to the actual graph? Is it pretty close? It's pretty close. But what is the slope of that red line? What is m? Can you see it's 3? Up 3 over 1? So when I say average rate of change on an interval, it's saying what's the slope on the interval. So let's look at the next set of data. From 2 to 3. So my value 2 is right there. Is everybody okay? That's my first value at 2. And then my next value is at 3. So if I go to 3, are you okay with that one? I'm going from 2 to 3. And then I'm finding the slope of that line right there. Now, is that blue line pretty accurate to the slope of the graph? Yeah, it's kind of close. So what would be the slope of that blue line? Can you tell it's -1? Are we good? So what we're going to be doing is finding average rates of change on intervals. So basically, we're finding the slope on an interval. If you look at this graph, can you tell that you have multiple intervals? Interval there, you have all these intervals. Oh, by the way, did you guys catch on to what this was? Do you understand these are the coordinates for that data? For that graph? Could I, watch this, could I, for the second problem, have just found the slope of that on the interval 2 to 3? See 2 to 3? 2 to 3, watch this. If I find my m, won't that be 3 minus 4 over 3 minus 2 equals -1? Now, how many think the graph is easier than this? Do a lot of you think I'd rather you look at the graph? You could look at the graph, or you can use the table. What's going to be happening on tests? I might only give you the table. I might only give you the graph. Are we good? You have to deal what's given to you and find the average rate of change. The next part is, on what interval does f of x have the largest average rate of change? Now, what largest average rate of change basically is saying is it's saying the steepest. All it's saying is, where is this steepest? So we want to find out where it's steepest. Where is this graph steepest? Well, it actually, can you tell it's steepest right there on that interval as well as on that interval? Doesn't this interval have a slope of 5? And doesn't this interval have a slope of -5? Aren't those both the same steepness? Just one's uphill, one's downhill, but they're both the same steepness. Kind of like if you were on a cliff, well, are you at the bottom of the cliff looking up, or are you on the top looking down? It's the same slope, it just depends your perspective. Got it? So since both of these are the same slope, they're both the steepest part of the graph. So What I would say then is there should technically be an S right there because it's intervals. The first one would be from -1 to 0. Can you see that? From -1 to 0. Isn't that the first one? Right here. Isn't that my first steepest part? Isn't the other one from here to here? And what interval is that? It's from 4 to 5. So the question 4 says, where is it the smallest average rate of change? Well, wouldn't that be the least steepest? The flattest, however you want to say that. So can you spot that one? If you look at the graph, can you see where it's the least or smallest? Can you tell it's right there and right there? Aren't those the two spots where it's the least steepest? So that would be from 1 to 2 and from 2 to 3. That is where my average rate of change is the smallest. Now, all that said, average rate of change, ready? Can you tell that closest to the vertex will be your smallest average rate of change? And as you go farther and farther to the right and left, isn't that where you're going to get your steepest average rate of change? The farther away you move from the vertex, right here, you get your steepest, larger average rates of change. The closer you are to it, has the smallest average rates of change. Be aware of that. The next part of the question is asking for when it's increasing and when it's decreasing. Well, if you're asking for a graph increasing, do you understand that's basically saying when is it going uphill? And when a graph is decreasing, hopefully you understand that is meaning you're going downhill. Are we okay with that? Increasing's uphill, decreasing's downhill. So if you look at this graph, can you tell the interval for which it's going uphill? Isn't it right there? And for going downhill, isn't it right there? Now, do you understand this graph technically keeps going forever down? And over here, isn't it forever up? Got that? Not forever, it goes until here. So how I'm going to write my answers are technically from increasing from -infinity to 2. Are you okay with that? The graph we see is really from -1 to 2, but we know the graph will keep going down. That's how parabolas work. So I can kind of assume future values. So from that, can you also say this is decreasing from 2 to infinity? Can you say that too? That from 2 to the right is always going down? Now, there's one thing I forgot to write on here. A function is increasing when? Let's get the definition of increasing. Increasing deals with slopes. What do you notice about the slopes as a graph is going uphill? As a graph goes uphill, what do you notice about all the slopes? They are positive. As a graph is going downhill, what do you notice about the slopes? Negative. So what we write here is the function is increasing when the slopes are positive, and it's decreasing when the slopes are negative.